Okay, it's time to start the session. The Google AR Android demo application deciphered by Mario Bodemann. Please start.
Hey, thank you. Thank you for pronouncing the title so awesomely. My name is Mario, right? Before I actually start with the content, I have to understand why my tool sometimes works and sometimes doesn't. Now it does. So, first let's explain what is this talk about. It's not about my company, so I have to remove that thing. So it's not about Contentful. I'm just gonna be for purposes later on. Okay. So I'm not taking over all of the stage, but I'm at least wearing my hat today. And I also need a parrot, right? So why do I need a parrot? Because at some point, a friend of mine was asking me, hey, do you want to give a talk? I said, sure, I want to give a talk. I was looking into AR at the time, and I was thinking, okay, what can I do that I can have a hook? Something that's a bit different for the late evening of a conference, right? So I kept thinking to myself, AR. That's what pirates do, right? So obviously I have a pirate talk about AR. This is how this idea got born. And if you don't like pirate jokes, sorry. If you don't like puns, sorry. If you do like AR, this might be also something for you. So let's go through this. ARrrrg scurvy dog, right? So some months ago, Google was announcing the ARCore. And I was taking a look at it and just finding out what this thing does. Oops, my bird moved into my eyes. ARCore is essentially helping you to find horizontal planes when you're looking through your phone. So you have an Android app running, which uses ARCore. What you are seeing is what the camera would be seeing, and then additionally the ARCore will take a look at the stuff you are seeing and finding points to then actually help you find horizontal planes. It uses the mixture of the sensors of the phone and also obviously the camera data. I can go further through this one, but let's just take a look at the demo, right? So, sorry, if you are building the app, it looks something like this. So this is taken in our office, and what you're seeing here is the grid pattern over here. This grid pattern is not actually in our office. It's just on this picture right now. What it does, it explains, it shows you where ARCore or ARCore found a plane in reality. How does it find the planes? It takes a look at the triangle, it's a rectangle. No, it actually takes a look at the points. So the green dots you're seeing here is a feature point. So this is a thing which ARCore, sorry, I have to say ARCore, right? Found in reality. So this is a stable point. So when I'm moving my camera, this point can be found again. With a lot of points this way, ARCore can then try to fit a plane into those 3D coordinate points. And the demo does not only display those points and the plane, but if you are tapping somewhere, which is denoted by the asterisk over there, you can actually place an Android. So this would be displayed on this one. So let me introduce you to Andy. Andy is a 3D object which, again, you can place everywhere. Sometimes it's important where you place it, because another feature of ARCore is that you can find out if the objects should be a bit dimmed or lighted up more, depending on the real scene. So if there is lighting in the area, it will be as bright as this one. If it's a bit darker, let's say in this corner over there, there's a bit more shadow, you can see that Andy is a bit more darker, which helps really a lot with immersion. So you could see that okay, in this darker scene, the Android is darker, so you might think a bit more, is there really an Android in this area? Obviously, there's the answer no, but yeah. So, okay, this is like the visual part of ARCore or the R demo. Let's go through the code because let's see what we are all interested in, hopefully. So the demo I was talking about comes in a package like this. So like this is directly taken from the GitHub repository, and I will go through some of the files. Let's start with the assets. So we have some images, which are the textures for Andy. For instance, we have the Andy PNG. It looks like this. So if you remember the Andy Android symbol, like this is what you would, like if you take, for instance, this thing and just put it on top of the 3D object, this would be how the texture, like how the result will be. So if you're, like those are the eyes. If you remember it from the image, it got mapped to the 3D object. Additionally, we have this one. For the ones in the back, there are 2 dots here. Like this and this part are darker, and the rest is like just blending out, going from something really dark to transparent. This is actually the shadow underneath Andy. So like you see where those dots are, this is where the feet would be. And then you have just a shadow created from there, which is like a nice idea to, again, add to the depth of the simulation. So like shadow is always important for your eyes. So the other thing is like this bird. God damn it. I'm sorry. The other thing is we have a spacey looking texture here, which is the, if you remember the plane surface. So here it is green, over there in the images it was white, and the white corresponds to how good the tracking was. So like if it's white, it means it's a perfect match. If it's red, it means it's like a kind of shaky match because there are not enough feature points found. So this texture is used, and through OpenGL functionality is then changing the color of this texture to be mapped to the tracking result. Okay, so this is like the textures of stuff. So how do I actually create a 3D object? How do I create my Andy? Therefore, we take a look into the Andy object file. Object file is from Wavefront. It's like one of the most standard ways of creating 3D objects. I have the full spec linked, so if you're going to my slides, which I'll share and already have shared, hopefully, you can see how this whole file format goes. So for now, I will just concentrate on the basics. So this is, again, the whole Andy printed. Like, it's not the whole Andy because what you're seeing, except for the comments, there are 2 vertices. A vertex is an edge. It's a like 3D corner point of an Andy, or of any 3D object. So it's defined in the usual X, Y, and Z coordinates. So in this file, there is like a bunch of edge corners. Sorry, that's a bit double, but hey. There is a lot of corners defined, just a bunch down the line. So for every corner point, there is one line, which is reading V, X, Y, Z coordinate. And the next thing is the texture. Like this is just, VT is a list of textures. So texture coordinates, to be honest. So this is just like, okay, if I find a 3D object, where does this 3D point or this edge be translated to the texture? So remember, the texture is like more 2D, and how does this map to the 3D object? This will be defined in the VT set of coordinates. The next things are normals. Normals are used for lighting. So there is a whole bunch of topic about how do I calculate normals and how do I do the right lighting. For us right now, it's just important, if I need normals, they can also be defined in the object file format. The last thing in binding all of those things together are the faces. So the faces are super interesting because in this case, it's like 1, 2, 3, 4 blocks of something. It can also be 3 blocks of something. This something is consistent of, now let me take a close look that I don't mix it up. Yeah, it's the vertex index. So like it's the index starting by 1, obviously, into this list of vertices. So like it takes the first coordinate. Then it takes the first texture coordinate and the first normal coordinate. And then it defines the next corner, like the next point, which is like now taking the second one from each. And this one is like now taking like just the tenth of the vertices, the tenth of the textures, and the third of the normals. So this way I can define that it's like a 4-point thing, so it's probably a quad, right? So if you think again in 3D space, with this face I can define, okay, I have 4 points in 3D, I know the texture coordinates of each point, so I can interpolate between those points to actually create a surface, which is like looking solid. Yeah, and the other thing I can do with faces is triangles, right? So instead of having like 4 points there or 4 triplets, I can have like just 3. But yeah, so like this is how you can this is how the object file format looks like. I'm ignoring those, and if you don't want to write it by hand, it's recommended to use like an a 3D modeling app. In this case, it's Blender, but I'm almost certain that a lot, if not all, 3D modeling tools are supporting the object file format. And if not, you can probably write a plugin super easily for it. Yeah, so like this is how you would create a model. This is how it's set up. Please don't start writing in the text file by yourself because it can get cumbersome if you are looking at, I don't know, several thousands of vertices. Okay, so this is the assets. Now let's go to the source. So this is the source, the complete source of the demo app, right? So we have something like helpers? No, those are not lit. What I found super interesting is like the package info.java. I've not seen, to be honest, in my Android career, a package info.java in an Android project. I think it's something coming from like business Java related things, and it's defining how if I'm looking at this kind of package inside the Java doc, what kind of text would I see? This is how I understood the package info. If there is something I'm missing, just come to me afterwards and we can talk about it. So, like, okay, this was quite interesting. Now let's go to the renderers, right? We can see we have a background renderer, we have an object renderer, we have a plane renderer, and we have a point cloud renderer. Like you can see, those are the objects we can render, right? Those are the things we need in order to display something on the screen. The background renderer is actually taking the camera feed and displaying it behind everything else. The object renderer takes like the information we just went through and displays the Andy in 3D space. The plane renderer, okay, I think you get the point, right? Like it's the plane, and the point cloud renderer are the little dots. This is what's happening inside, for instance, the point cloud renderer. Please don't look at the code. It's like, you can summarize it a bit easier if I'm just going through the stubs. So like you have something like fields defined, and I'm sorry, but. So the fields are essentially there for saving OpenGL features. So if you are creating this renderer, you have to store specific OpenGL names. Like if you're creating, for instance, a shader, you have to save the name of the shader in the field so that you can access this in the other functionalities. So this brings me to the create OpenGL thread. There's an on missing, create on-GL thread. This method has to be called from the OpenGL thread. So this means there are more than one thread available in this application. So we have the UI thread, and we have at least the GL thread. Luckily, you don't normally have to be concerned about this too much, because if you're using like a surface view or something, Android takes care of this functionality, and you just need to be aware in which thread you are calling it. So if you are calling OpenGL functionality, you have to do it on the OpenGL thread. Otherwise, you will get an exception, if I remember correctly. So the create on GL thread, this one creates the object. So what is needed for creating an object? In this case, for the point cloud renderer, you need a so-called vertex buffer object. This is essentially memory on the GPU. For creating it, you have to create it with the right OpenGL calls, then you have to bind it with the OpenGL call, and then you have to put data on it in the update method. So this is how you get the data, right? So like now I know where my points are in space, but that's not all I need for rendering. I also need shaders. I need two kinds of shaders. I need a fragment shader and I need a vertex shader. Okay, vertex shader is for, I have my 3D object defined, and now I want to put this 3D point onto my screen. I need to use a vertex shader for this one. And now I have my point on the 2D surface, and I have several points connecting to each other, so I want to render the pixels between those 3D points. This is a fragment shader. If I have those, I can create a program. And then I can bind this program, and this tells OpenGL, like, now use this program to actually render everything that's coming in. The funny thing for me when I was looking at it, at OpenGL the first time, is I'm actually asking OpenGL to compile my shaders. So I'm giving it just a source file in strings, and then it runs through the driver and creates the binary of the shader, and then binds it into a program. That's like super interesting because I didn't think that inside my Java app I have another compiler running which compiles the shaders for me. But yeah, so like once all of those steps are done, you have created the objects. So the next things you need to do is like updating it, which is essentially like you remember the vertex buffer object. It has a name. You just tell it, okay, now here's new data, upload those data files, those data elements to OpenGL. And for actually rendering, this is like another whole bunch of topic because you have to set up from the shaders also the unions and the attributes. So like you have to find out which place in memory I need to take the coordinates to and those things. If you're interested in this and we have a bit of time, I can walk you through this on the source code level. Or if we have time at the office hours, just come over and we can talk more OpenGL. That's also why I'm so sorry that this OpenGL talk before in Japanese was canceled, so because that would have been probably totally interesting. But yeah, so this is the example of a point cloud renderer. The others are more complex. So if you are taking a look into the object renderer, you obviously have to like calculate how the object file works and how this aligns with OpenGL. So I will not talk about them here right now. Instead, I'll talk about my favorite, the hello ARRrrg activity. So why is it my favorite? Not just because the emoji is awesomely displayed there, but I don't know how to say this. It does everything. So it takes care of the UI. Like if I tap on the surface, it takes a look into like, do I hit something? It takes a look into like the ARCore bindings, like do I need to update my understanding of the reality or is this fine? And finally, it has also fields for every renderer. So it has exactly one object renderer, and this one is saved in the field, and it goes through this lovely onDraw frame method, which looks like that. It's 107 lines of code. One method. And if I try to find out where's actually like the tap happening, I feel kind of reminded of finding a treasure. I don't know why, but so because I don't know, like here looks probably also from behind. You can see here's a kind of space, so there is something entangled there. So it's in a for loop with touches and. Sorry, I think this is super hard to understand at first. So. Here is where I came in and said, like, hey, let's try and see if I can get a better understanding by tinkering with the code, right? What I did is I played with my fork. No, I actually forked the code because it's like open source on GitHub. And sadly, on their README, they say they don't accept pull requests, so I forked it. If you're interested in the GitHub repository, it's like small down here or big in the QR code. It's like Mario Bodemann, which is my name, /PirateAR on GitHub. You got it? Take your time, sorry. Thank you. Yeah, so Obviously, since I changed it from 16 to 9 to 4 by 3, now the position of the pictures is wrong, but don't worry about this. This is my job to be worried about it. Because the main feature of the fork is it has a way nicer icon. Okay, yeah, again, maybe it's private, I don't know, it's taste, right? But honestly, it has a clearer separation of code. So what I mean, I will obviously go through in a second, but like you can render more objects with it, and the APKs are actually in the repository, which is like, okay, you normally don't publish binaries there, but I just thought, okay, if somebody wants to test it out, just go to my repository, click on the APK, and install it on your app. So also here, we go visually through it first. This is obviously Andy, but we also have ARrrrg, the AR animal, right? And this in the corner here is Connor Contentful. So I have all my favorite key reaches with me, and I can put them on somebody else's hand and change them on the fly. So this is like visually the difference between my demo and the demo from Google, which is obviously awesome, but yeah. So how did I do this? If we take a look at this super working slide, this is a representation of the AR demo. In the hello AR activity, essentially everything happened. And what I did is, like, as a pirate, I want to conquer more things, so I divided it. So for me right now, the hello AR activity is just taking care of the UI handling. And everything that is like happening with 3D is, with tracking and actually objects is handled in the scene, and the scene redirects the rendering calls again to the renderer. The funny thing about the scene, it's like not to be confused with the scene graph because it's more a scene list. Like I don't have objects inside of objects, but like it's just something you can think of later to add it there. Also, I will not show this code here. It's again teasing for the office hours, right? I'm just gonna go through this on a higher level. So this is essentially what I said. What I additionally added is the ability to load the object files from the external directory. So like every part of the app can now contribute into creating 3D objects and textures and just make the renderer be aware of it. Which is like the way how I introduced like the 2 other objects, or actually the 3 other objects, by just providing a 3D way of like just a way of finding them in an external directory and not relying on the assets. My favorite thing is the on-draw frame. It's still, I could it only cut down to 60 frames right now, so if anybody has a better idea of it, just I'm open for PRs or let's talk about it. But again, it's like 60 lines. It actually fits in like font size 7 on one slide. What it does here is like, it only does OpenGL setup calls and then tells the renderers, please now render the thing. And the renderers I have inside a loop somewhere here, down here, and I don't even know how many objects I'm rendering or what kind of objects I'm rendering. I'm just redirecting the responsibility here. Also, what I moved out, as you saw before, there is no on-tap handling in here. In the demo from the Google guys, there was like a big for loop inside going through like all the time. Between 2 frames, I tapped on a screen. There could have been several taps and finding out which place is now the right one. I just extracted it and put it into the main AR activity. And now I do the thing you asked me not to do. I would like to show you some code. Who is in for watching some code? Okay. So let's see what's happening if I do that. It just works. So this is the on-draw frame. Who can see it? It's an inverse question. You can see it? Okay, so if you can see it, then I hope the rest can also see it from there. Thank you. First call is GLES 2.0, right? So this means we use OpenGL embedded system 2.0 for the rendering. This is like a static call, but it's like the way Android use OpenGL. What I do there is like I clear everything. So this might not necessarily be needed because like we are showing always a background, right? So we always show the camera feed, but this was just taken over from the Google demo. So I clear everything in the frame buffers, or actually in the secondary buffer before I swap it. If I'm talking too much and I'm losing you, just tell me, okay? Also, he just told me it's fine. So I will just go through this one quick. So yeah, it takes a look into, like it clears it and then finds out, okay, do I need to rotate the screen or do I need to tell OpenGL like, hey, your width is now your height because you're going from landscape to the other one and from the other one to the landscape. The next thing is I take the session. So the session in this case is the ARCore session. It's like the understanding of ARCore, what is the reality. From this session, I take the frame, and the frame is like the specific instance, like what's now, so to say. And if you can see it, yeah, okay, this is like the feed renderer, this is all fine. The funny thing is down here. Like I get from the frame the camera, which is like an object somewhere hovering in mid-space, and from there everything is shot. And what I need from this camera is the projection matrix and the view matrix. Projection matrix is, again, mapping everything to a 2D surface, and the view matrix is like, where does it be, and where is it in space? It's a 4x4 matrix because it's projective matrix. If you need more knowledge, sorry. I can probably rig something together there, but it's been too long that I actually had to deal with matrices and like how do you combine them. Luckily for me, ARCore takes care of this one. So I just know I have to take them and tell this my shaders and my objects, and then it's taken care of, which is good. So once I got all of the matrices, I can like start finding my mouse and scrolling down. So we stopped somewhere here, which is probably not visible, but oh, sorry. Yeah, the other thing which I mentioned before is that I can make the Android darker, right? So, and in order to make the Android darker, I need the light intensity, which is the way how ARCore defines, do I need to make it darker or is it bright enough? So sadly, what would be awesome is if I could find out a way where the light is coming from. Right? But that's future music. We can't do this right now. So I take this float value, essentially, and it says, like, OK, it's a value between 0 and 1, and I multiply all my colors with it. This is how I make the Android appear darker. And the next, so like, yeah, I tell this all of my renderers, if I'm correct, which is like also further down, and I don't know, do I still have time? 2 minutes, okay. Yeah, so I just save the light intensity after I have the matrices, right? And then I go to the point cloud and say, okay, just now update your current understanding, like go to the ARCore, get me the points you found, and update it onto my point cloud renderer, just to bring it in one more time. And the next thing, after I updated it, I can draw it. Again, I use the matrices to draw it, and then at least the point cloud renderer and the background renderer are done. So the next things are the actual other objects flying around, which this one I will just ignore, because this is a callback. Once I found a plane, I can tell the main activity to remove the UI on top of it, that it says, like, hey, I have not found any space yet. And the last part I need to go through is this one. This is essentially the magic. So I have a for loop about the object renderers. So, and every object renderer knows its position in space, knows the object it needs to render, knows the shader, knows the texture to render. And if I'm finding out that I found a plane, I'll just update my current understanding on where this object should be, because like maybe I found better understanding on what the plane currently is. So the object I put there is actually over there. And then when I have updated the matrices, I can actually draw the object, which is something I can go through, but I think I don't have enough time. Right? So because it's like a super big message and method, and again, I just say, if you want to meet me, that does not work. I have somehow this one, yes. I summarized, right? Demo is great, even if it works. Take a look at the AR demo, right? Take a look at my repository if you like, and if you have like some feedback or something, feel free to play around with it. And for me, it's now finally time to say, I have birds. So if you need more birds, which probably everybody needs, I give them for good questions. So sadly, you have to come with me with a good question. Sorry. Or you just come to me and talk to me. That's also fine. But thank you so much.
Thank you for the talk.